Hello guys, good morning and welcome back to our video tutorial. So what we have today is that we're going to be talking about Ethernet, which is a layer 3 protocol, and we're going to say, because the last time we had a video, was it yesterday, we were talking about layer 1 and layer 2. So together here today also we are going to go through some the same layer 2 protocol. So the video for this theory part here right now would not be that long, because I have to also go to the board and make another video tutorial and explain the difference between a switch and a hub, and even with a router, and explain the switch and the switch behavior properly, so we understand that side. So we're just going to make a demonstration, a quick explanation right here, and then we go into. So here we have Ethernet. What Ethernet is, that it is a traditional technology that is used to connect devices in a local area network or connecting devices in a wide area network. And what Ethernet does exactly is that it enables devices to be able to communicate with each other via set of rules. Okay, so that is what Ethernet is. It provides connectivity between devices and make sure it controls the communication between those devices, providing a set of rules. And Ethernet is a physical layer protocol, or one can say a data link physical layer protocol, which provide a wiring over which the data will travel. So that is what Ethernet is. So basically we're just going to go to through the objectives of this chapter. The objectives of this chapter include the following. Oh, I don't know what happened to my device. Oh, my device is getting crazy right now. So guys, I hope you're following. I have some issues with my device just recently, so I have to avoid any problem. So this is the objectives of this chapter, that we're going to explain Ethernet protocol, which I just did, and explain the operation of the Ethernet and the MAC sublayers, that is the LLC and the MAC sublayer. We're going to talk about those two and explain the switch behavior and talk about the address resolution protocol. So I'm going to explain this address resolution protocol in a separate video, and also the brief explanation on this switch. I'm just going to do it quick one, and then my next video will make a broader explanation about the switch behavior and how the switches and this ARP comes about. Okay guys, so we go into the Ethernet. So Ethernet is the most widely used LAN technology, like I said, in today's technology. And what it does is that it allows devices to connect within a LAN or in a wide area network. And what it supports different bandwidth ranges from 10 Mbps to the legacy 10 Mbps to down to 100 Gbps, so to 200 GBs. So Ethernet operates at the data link layer and the physical layer, like I explained previously. What it does is it operates at the physical layer and allow layer 2 protocol, frames to pass through or to travel through this Ethernet at layer 1. So that's why they say it operates both at layer 2 and layer 1. So Ethernet relies on two separate sublayers of the LLC, of the data link layer, that is the LLC, and the MAC sublayer. So like I said in my previous video, that the data link layer is the only layer of the OSI layers that is further divided into two sublayers. So let's just talk about those two sublayers in brief. So the Ethernet LLC sublayer handles the communication between the upper layers and the lower layers. It is implemented in software, and its implementation is independent of the hardware. So therefore, MAC sublayer operate between the upper layers and the lower layers of the OSI layers. So the MAC sublayer, what it does is that it constitutes the lower sublayer of the data link layer, and it is implemented by hardware, typically in the computer's NIC. So that's why your computer's NIC has this MAC address information, because this is what constitutes the function of the data link layer and the physical layer, and how the device will have access to the network. So the MAC sublayer has two primary responsibilities, and which you may face in your exam. What are the following responsibilities provided by the MAC sublayer of the data link layer? It is data encapsulation and media access control. You may also be asked in an exam the functions provided by the data encapsulation of the MAC sublayer. These include frame delimiting, addressing, and error detection. So we're going to talk about these three, and we understand what they are. Then the media access control is responsible for placement of frames on the media, and then it will also make sure that those frames are removed from the media and make sure that they're placed in the right place. If not, it will be able to remove them from that and place them somewhere that they're forced, whether it's going to drop them or it's going to discard it somehow. So the sub layer communicates directly with the physical layer to see what would be done with a particular frame. So since the 1970s, Ethernet standards have evolved, specifying faster and more flexible versions of technology. We have 100 Mbps, 1000 Mbps, and so on and so forth. So early versions started just with that, 10 Mbps, and today we are talking about 100 Gbps. So that is where we are right now. So the minimum Ethernet frame size for Ethernet to travel across and for a frame to travel over the Ethernet, it must have to meet the minimum frame size of 64 byte. So if an Ethernet is receiving a frame that travels across it with less than this minimum frame size, the Ethernet will drop that frame and see it as what an invalid frame, because the frame must be between the range of 64 and 1518 byte. If less than 64 byte, it is a jumbo frame or a round frame, and if it is more than 1518 byte, it is a giant frame, which is not good. So frames that are less than 64 bytes are not good. At some point they call collision fragment, or you can call them the round frames, and they're automatically discarded. Discard, for you guys that may have problem with English, it's talking about dropping it, okay? It's talking about ignoring, voiding it, and putting it in the trash. So that is basically what it does. So frames that are more than 1500 bytes, 1518, 1516, whatever, they are they're considered as jumbo frames, and they are not good frames. They will also be discarded. So if the size of a transmitted frame is less than the minimum or less or greater than the maximum, the receiving device will drop that frame, and which is very good. So that's why frames have the frame check sequence at the layer 2 to make sure that frames are checked, and then it also has some CRC, cyclic redundancy checks, that will be run on a frame to make sure that it meets the maximum and the minimum requirement of frame size. So guys, you guys will have to understand that an Ethernet MAC address is a 48-bit. What is a MAC address? A MAC address is the address of a device in the network, and every device is a layer 2 address called a physical address that is used for a device to identify itself in the network. So this is assigned in two ways. That it is assigned vendor side. These are assigned by vendors, but they also have an organization called the Organizational Unique Identifiers that will give another part of the address to your device. So this address is embedded into your NIC card, and it is seen in a form of hexadecimal digits of 4 bits per hexadecimal digit. So the hexadecimal is a representation of numbers and letters, where we have numbers of 0 to 9 and letters of A to F, where A represent 10, B represent 11, and C represent 12, D represent 13, E represent 14, and F represent 15. So I'm just gonna have to make a short video of how to get this and how to convert these hexadecimal values to binary, which is going to be our video that I'm going to release to you guys. So I'm gonna give you handy of videos today, maybe 4 or 5 different short videos for you guys to understand all of these things. So hexadecimal, like I said, is represented in that format. So it will convert, in our next video is that we're going to convert from decimal or from hexadecimal value to binary. Decimal will come in our subsequent videos as well. But in our today's video, we're just going to have to deal with hexadecimal values being converted to binary, and from binary to hexadecimal, vice versa. So the MAC address were created to identify the actual source and destination. So the MAC address rules are established by the IEEE. So like that I said, the MAC address of a device is 48 bits hexadecimal bit values, and then they are used to identify a device in the network. So in that case, the MAC address is 48-bit divided into 2. The first 24 bits are assigned by the Organizational Unique Identifiers, an organization that is responsible for numbering of MAC addresses, and the vendor assigned. Let's say, for instance, if this device is manufactured by HP, for instance, or Dell or whatever, they are responsible for providing the last 24 bits for the MAC address to be completed. So all MAC addresses are assigned to a NIC, and those NICs are components of the data link layer. So like I said in my last video yesterday, that MAC address also have different names. You can call it layer 2 address, you can call it data link address, you can call it physical address, you can also call it the MAC address. So all is very, very important that you know all those different names. So all MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. So that is done by the vendor. So the frame processing for switches or for a device in the LAN segment or at the layer 2 is that devices would take note of the MAC address information for forwarding decisions. So a device communicate, like I said, most of communication in my previous videos are unicast, multicast, and broadcast, which will be understood in these videos coming in. So first, what happened is that when a frame is received by a device, it will have to locate the MAC address of the destination device within the same LAN. If it is a different LAN, this device that is receiving this frame will have to look up for the default gateway IP address and then forward it to the MAC address of the default gateway, which will be a router or any other device serving as a default gateway. And then at the recipient side, the device will have to locate the MAC address of the recipient and forward it. So when a device is forwarding a message to an Ethernet network, it will attach header information, which is the MAC address to the frame. This MAC address identifies the destination of the frame within a LAN or outside. So in order for you to see the MAC address of your device, you can use this command ipconfig/all, and if you use this command on your command prompt, you would see one physical. You will see the physical address is what I mean here. So when you see physical address, it is the MAC address. So some MAC addresses are written this way, separated by dashes, some with colons, some with dot. So your device would depend. Maybe if you're using Windows XP, you may be having dot. So but others will be having colons and others will be having dots. So it doesn't matter. What matters is that you see physical address down there. So like I said, the modes of communications we have unicast, multicast, and broadcast. So when a device from the same LAN is communicating with another device at the same LAN, then the destination MAC address will be identified and then the packet will be communicated directly to that device. But we're going to make a broad explanation on that one, a broader explanation on that in our next video today. So what is important right now is that you remember this multicast, unicast, and broadcast. So a unicast MAC address is the unique address that is used when a frame is sent from single transmitting device to a single destination device within the same LAN or outside of the LAN. So that is communication directly from one device to another device. Next one is broadcast. A broadcast is done when a device needs to communicate and search for information from other devices. Let's say, for instance, I am in this room. I just came to the classroom and I don't know who is Get. I don't know who is Farmer. I just come and say, who is Get? So when I say who is Get, my communication is broadening. I mean, I just sent my communication out and then I'm listening to my recipient. So I do not direct my communication to any single person. So with that, who is means I am now broadcasting my information. So as soon as I put Get, now Get will respond to me. In the response between I and Get, the first time I am broadcasting to ask for who is Get. So my broadcast will have to go to all devices except myself, because I am the one that gives this information, so the information will not come back to me. I broadcast it to all the devices, all the students. So Get will now have to respond to me and tell me exactly that it is I, then I'll respond to him back. So first he's gonna, so the broadcast address for all devices within the LAN MAC address, the broadcast MAC address is all F. So if you have all F, that means all 41 bits are set to 1. Okay, so we're gonna have to look at how to convert those binary conversions. Okay, and also multicast MAC addresses or MAC addresses that are used to communicate to a group of devices. So like I said, multicast is basically for devices within a